Hi there. This is Bill Inman. This is the second day of our symposium on the Data Lakehouse. Very briefly, yesterday we made the point that there's three kinds of data that you typically find in the data lake and data lakehouse. We find structured data, textual data, and machine-generated data. We're not going to spend any time talking about structured data because most people have a background in that. But we're going to be talking today about text and visualization and analysis from that kind of data. Now, as we said yesterday, the data lakehouse is like an orchestra. There are lots of different pieces to the orchestra: the violins, the cellos, the flutes, the drums, etc., and so forth. And yesterday we heard about data lineage, which is like hearing about the violins play. Today, we're going to be hearing about text and visualization, which is like hearing the flutes and the French horns play. So that's what we're doing today. And later on in the symposium, we're going to be hearing about the infrastructure and the machine-generated data from our friends at Databricks. Today, I want to introduce two people to you. I want to introduce Dave Rapine. Dave Rapine is from the University of Cincinnati, and Dave Rapine is going to talk to us about text in the data lakehouse. The second person I would like to introduce to you is Dr. Valerie Bartel. Dr. Bartel is a professor at Denver University, and she's going to be talking to us about visualization and analytics of what can be done in the data lakehouse. So with that introduction, I would now like to turn it over to Dave Rapine.
Thank you, Bill. So as Bill said, my name is Dave Rapine, and I am a partner in Forest Room Technology and an associate professor educator at the Lindner College of Business at the University of Cincinnati in operations, business analytics, and information systems. And today we're going to talk about text in the data lakehouse. So when you look at your company, well, before we look at our company, we need to look at the history. As we look at the history overall of the orchestra, we want to look at the history of what's gone on from major historical changes in data collection, data storage, and data usage. In the 1980s, the data warehouse was invented, was conceived, and showed us and allowed us to hold a single version of the truth, to make enterprise-wide decisions. And through Bill's leadership, we've been able to use this for the last 40 years. Now, in 2010, the data lake allowed us to collect more than just that structured data. We understand the structured data, but now we're able to collect a lot more different types of data in one place. And that allowed for a centralization of our company's entire set of data. The problem is we'd collect data and collect data and collect data, but we had no understanding of what it was, and the data lake becomes a data swamp. In 2020, the data lakehouse married the data warehouse and the data lake to it by adding data governance and metadata to the data that was coming into the data lake. They were curating the data that came in so it could be separated and separately transitioned into a data warehouse or consumed by decision makers and analysts. So that's where we are right now. And we're going to talk about textual data that has moved from the data lake into now the data lake house. So my question to you, where is your company's data focus? Why do you collect the data that you collect? And what is the focus of your data? Are you collecting data for future use? I know that we'll use all of these streams of tweets. I know that we'll use all of this information in the future, but we better collect it now so that we have it for the future. Is that your company's data focus? Is your company's data focus for business decisions now? Are we looking to make business decisions at this point in our time? Is our data focus on analysis and research? I want to collect data so that we can analyze what we're going to do and find new ways to interact with our customers, to retain customers, or find new and innovative products? Or does your company not have a data focus? Do we just collect data, but we have no focus for that data? That's unfortunately where many of us are. So the next question is, what types of data does your company collect and store? So what are you getting? What are you bringing in? What are you putting into your data lake or data lakehouse or data warehouse? Are you pulling in all the transactional data from your source systems? Are you looking at the customer interactions data? Are you pulling in machine-generated data, Internet of Things data, analog data from all of the sensors and cameras around your facilities and within your with your customer interactions? Are you collecting emails, blogs, customer reviews, medical records, contracts? Are you collecting all of this types of data and storing all of this types of data? Are you collecting images and videos and scans and audio files? Are you keeping all of this data? These are the questions that I want to come into this part of the presentation with. So what will we talk about today? We're going to discuss in today's presentation types of data in the data lakehouse. Then we're going to move straight into the textual data in the data lakehouse. What is it? What can we do with it? Is it situated within our company? And then what is needed to make use of the textual data in the data lakehouse? This is the presentation that we're going to try to go through, and I'm glad that you're here with us. So what types of data are in the data lakehouse? Well, a data lakehouse can host all of your corporate data. But the nice thing about the data lakehouse, it is curated. It has data governance. It has metadata assigned to it so that we have understanding about the data that we're storing. And so within all the curated data in the data lakehouse and data warehouse, we have structured data, we have textual data, and we have analog or Internet of Things data that is being pulled in and generated by machines. It's less than 20% of the data that we store right now is actually structured data. It's transactional data. It's coming from a database. It is being able to be stored in a database or a data warehouse or a data mart for usage. About 80%, over 80% of our data is textual data and analog data. Machines generate massive amounts of data. And we as people, we love to talk. We love to type. We love to put things into emails and blogs and reviews. Over 80% of the data that is stored in the data lakehouse is textual and analog data. So I suppose Pareto's law, the old 80-20 rule, holds true. When you look at the data used for decision-making, over 80% of the decisions are made using less than 20% of the data. Less than 20% of decisions that are made are used on the 80% of the data. So if 80 to 90% of business decisions are made on less than 20% of the data, is something wrong here? Are we missing something here? Well, we understand how to do stuff with structured data because for the last 40 years, we've been able to do that. So what are we talking about within the structured data? Within the violin section, within the percussion section, what are we talking about in this area? We're talking about data warehouse data, physical models, tables, aggregated data, scrubbed data, metadata that's on there, and all of the politics that went into the data governance to make sure that we understand and define the data that is going into our data warehouse. What kind of data are we talking about with textual data? It's all of your documents, your emails, your contracts, any medical records, voice of the customer records, insurance claims and call center data and transcriptions and other things that we have decided to store. But what do we do with it? We have all of this textual data, but it's just sitting there. And then we also have analog data. This is all your automation data, your location data, click streams. Every single time that a person clicks or moves their mouse, and I want to know that information, how they've interacted with my websites, all the sensor data where every single car that has gone in and out of my parking garage or through this particular intersection, all your audio files and video files, all of your security cameras, and other types of images, anything that is machine generated. These are the data types that we have. If we look at the relative volumes of data, structured data is exponentially less data than the textual data. And the analog data is exponentially more than the textual data. But when it comes to using this data for business decisions, it goes the opposite way. Most of our data, most of our decisions are made from structured data. Some are made from textual data, and not as many are made from analog data. So what's going on here? How can we make use of these types of data? How do we currently use the different types of data? Well, the structured data we use for a data warehouse. We do timeline analysis. We do 360-degree views of the customer. We do some data mining. There's lots of really great things that we can do with structured data because we've had decades to build these analytical tools. With analog data, this is really structured data. We have data that it's solid, and it's coming in from our machines. It's coming in from my Fitbit. And I know how many steps I've gone. And machines can learn more about people because the data is so structured. We can start doing machine learning. We can start doing artificial intelligence, all from analog and Internet of Things data to make sure that we know when machines are going to break down before the machines are thinking about breaking down. And we can fix them before they become a problem. But what about the textual data? What can we do with it? Well, we can do manual analysis. We can look at each document one by one and try to find out what's happening with those documents. We can get 1,000 people in front of 1,000 computers and try to figure out what's going on. We can use NLP. Now, that's not necessarily a great tool for doing analysis. It's a really interesting tool, and it's made leaps and bounds, but that allows structure of the sentence. It allows us to understand better how people talk. But can we do analysis with that, or is it really for document markup and to find if we have subject-noun relationship or if we have sentence structure properly stated? Is it the right tool for doing analysis? Well, we can have failure. It's been proven in the past by using the previous tools that we can spend a lot of money, a lot of time, a lot of effort, and end up with failure. We could use textual extraction, transformation, and loading, textual ETL, but we'll talk about that as we go through. So, what is textual data in the data lakehouse? Well, what data are you missing in your analysis? Are you missing contracts? Analysis of contracts, medical records and insurance claims, emails. You are keeping so many emails. 300 billion emails are sent every single day. And my bet is you haven't deleted a single one of them. You've just put them into different categories. By law in the United States, we're not allowed to delete emails for up to 7 years for many legal reasons. But we have real estate deeds and internet files, HTML files and dictations and voice of the customer documents. We have transcriptions and Word documents, CSVs and Parquet files. All this type of data is textual data. There's text in that data. And we have not been able to use this data, but we sure as heck are storing it. We sure as heck are keeping it for future use. Well, what can we do with it? So what's similar about most of this textual data? Well, it's stream of thought. It's an email that I want to talk to somebody else about. It's my understanding as we go through, and it's a stream of thought. So that's one piece. And it's in different languages. It's in different sentence structures. It's with different inflection. It's different document by document. Even when you have the same documents, it is still different because someone else may have written that document, or there's particulars about the documents that cannot be massively in mass worked with. It does not have primary keys or foreign keys. We can't guarantee the person who the document was to or who the document was from. We cannot specify these pieces in the way that we can with structured data. It has little format. Yes, it can have some format, but it doesn't generally have a format that we can work with. This is the key. Textual data is dirty data. It does not have keys or referential integrity. It does not have proper sentence structure. It's dirty data. Nothing about it's guaranteed, but we're still storing it. So how can we use this? Well, here's the issue. The modeling and design techniques that work in the structured world just don't work in the world of text. They don't. Why? Because people do not write or talk the same way that is found in the structured world. We don't talk in columns. We don't talk in CSV files. We don't talk in XML. We just talk. So what is being used in certain areas cannot be used in this world. So think about it. You have a little bit of structured data, a lot of textual data, but in the structured data, you're talking about keys and attributes and indexes and physical models and ER diagrams that we understand. You have snowflake designs. You have all kinds of dimensional data that we can deal with. It's structured. But in the textual world, we have, I was looking at that nice colored sweater in the window. I wonder if I could try it on, but I don't even like the sleeve length. What? These two worlds are not the same. They're completely incompatible. In order to address text, you need a completely different approach. So now we get to the crux of why you're here. What is needed to use textual data in the data lakehouse? Well, let's go back and consider the types of data that we're storing and not using. All the call center data and the Yelp reviews and the voicemails and the PDFs, all of the data that we're storing, but at this point, we're not using. So what we do need to do first is we need to organize. We need to organize all of our documents and convert each into a standard text format. So what are we talking about? Well, we look at our general documents, our emails, our Word documents, our call center documents, our HTML files or internet files that we have. They're just general documents. And honestly, they're generally in the form of text already, which is nice. Maybe not perfect text, but they're in text. We have tabular data. Once again, this is generally in the form of text. We have Yelp reviews and CSVs and Parquet files and voice of the customer files that are coming from the vendors who have helped us to listen to our customers, gotten the surveys, and then made use of that. So those are all tabular data, nice and in columns, sorted and in rows so we can get the information a certain way. It has a little bit more structure to it. We have audio files, voicemails and dictations, which turn into transcriptions. So we do have the audio data. We have files with some format. Contracts have a format. Warranties have formats. Insurance claims, these have formats. They have specific pieces of information that you want to have in certain areas. They have, we can classify these. We know with a contract who it's between or who it is among. We know with warranties what it's for, the products is for, and who's bought the warranties and how much they've paid. Medical records do have a format. Now, if you're using Epic for your medical records and you want to export your medical records, there is a format that we are going to print those with or use with Epic. And if another company has, let's say they have Epic, then the format will be completely different because this office likes it differently formatted than that office, despite the fact that we have the same vendor, that we have the same software, but my preferences on how I deliver my medical records are different. But when it comes down to it, we always have certain things that are required, not just by law, but by common medical understanding. You have to have SOAP notes, subjective, objective, assessment, and plan. You have medications, and you have the customer's client history, the patient history. That may be a whole series of visit by visit by visit by visit. So these do have some format. And then you have things that are just mixed. You have PDFs. A PDF can be a mixture of of text and pictures all jumbled up all over the place. We have document scans that we just scan in document after document. What do I do with these mixed format pieces? The answer is we need to convert everything into a standard text. So we're going to use, for general documents, we're going to use converters to convert Word documents into a standard text, or call center documents, HTML documents. I'm going to strip out the HTML and get the text that I'm looking for. I'm going to, on the tabular data, I have the columns that are textual columns. And I do have additional information, but I can find out what columns I actually need. In the audio data, we use Dragon Speak or other types of transcription software to take your voicemails, take your dictations. On my Pixel phone, it does it for me automatically and saves it for us. For these great interactive platforms like Teams and Elite Studio and Zoom, it will actually give you full transcriptions of your entire meeting. But now we have all this transcription along with video and audio, but I need it down to a text. We have the ones with some format. We are going to use a concept called inline contextualization. We'll get to this and explain what it is. This is a child of Bill Inman that has lasting effects and profound understanding or effects for your documents. And for mixed documents, we're going to use optical character recognition and then convert it into a standard format. So once we organize everything and convert it to a standard format using these types of converters, we can convert everything into a textual format. Now, great. Now what do we do with that data? Now that it's just in the form of text, what do we do with it? Because we have the same problem. It's just that now we have two documents instead of one. Well, the first thing we might need to do is de-identify the textual documents. We are going to need to redact some personal data, because if we're storing it up on the cloud, if we're storing it in a different data store, we may not want to know the patient information directly. It's not the patient that we're worried about when we're dealing with 10,000 patients. It is the dimensions of the patient that we care about. So we do, in many cases, need to redact personal information from these textual documents. And what's nice is since they're all in the form of text, we might be able to do that. And then magic happens. We will apply context. So here's the deal. If you're going to address text, if you're going to address all this textual data, you must have a handle on both text and context. Context is understanding what the text is about. Context is understanding what we're trying to say in the document and in what context those documents matter. It's not sufficient to merely address the text. Furthermore, most of the context that is needed for use lies outside of the text itself. The context is not in the document. The context is the business use of the document. The fact is, you can analyze your text until you're blue in the face, and you'll never find relevant context of the text that is useful for analysis, that is useful to make business decisions. Because the reason that we're using a data lakehouse, the reason that we're using a data warehouse, the reason that we're storing all of our Parquet files inside our Internet of Things and analog files is to make business decisions that will advance the cause of our business. And in the textual world, you need to know the context of those documents in order to better understand. Text is relatively simple. All of the stuff we've gone through up till now, it's relatively simple. Context is 90% of the battle. So, what's the purpose of you spending this time with me? Well, the key is, if you can properly apply context to your documents, you can convert your unstructured textual data into structured data. If you can convert it into structured data, you can now use your textual data for structured analysis. You can make business decisions using all of that massive amounts of textual data. So let's go back. What's meant by the context of textual data? Well, honestly, it has different meanings in different areas. You will understand this for your company because your company has focus. Your company has an idea of what it does. Your company has ideas of what gives you the competitive advantage, or what are key KPIs, key performance indicators of your business. So consider the word trust. We all know what the word trust means. Trust. It's trust. So it's simply, in friendship, it's the ability to believe in the word or the action of another. It's, I trust my friends. I trust you, you trust me. This is a basis of the word trust. But wait, that's in the context of friendship. What about in the context of finance? A trust is a legal vehicle used to pass and allocate assets from me to you. It is a trust. But the word's trust. Yes, it means different things in different areas. Oh, well, what about in networking? If you're dealing with a trust relationship, it allows one computer to communicate and share with another computer, because within this computer network, within this domain, we have a trusted relationship. This is the basis of trusting your Bluetooth phone to work with your Bluetooth enabled car. It is a trust relationship. So when we're dealing with context, and I use a simple word like trust, it has tremendously different meanings in different areas. So I need to know what context the word trust is. And NLP doesn't do that. NLP just says whether or not this is a noun or a verb or an adjective or an adverb. Well, let's look again. Context also means different things in similar areas. Consider the word cervical. Cervical in the medical field. So now I know I'm dealing in the medical field. Cervical means, well, pertaining to the neck. It means it's pertaining to the neck. So we have a cervical vertebrae. So if I'm going to be dealing with a spinal injury, I need to know if there's an issue with the cervical vertebrae in my neck. However, it also could mean pertaining to the lowest segment of the uterus. So I could be dealing with cervical cancer. I could be dealing with a cervical hemorrhage. And I need to understand which cervical am I dealing with, despite the fact that they're all medical records. Are we dealing with cervical up in the neck or down in the reproductive organs? What are we dealing with? It has different context, even in similar areas, and it may have different meanings completely in related areas. Consider the word dermatome. It is a medical area. So it's one that we're all familiar with, of course. Just so you know, just in case you weren't, it does mean it's an area of the skin supplied by a specific nerve root. So I now have a dermatome, which is this particular area of the skin, and this nerve root is going to work with that area of the skin. It's a dermatome. However, also in the medical field, it's a surgical instrument used to cut the skin. So if I see the term dermatome, are we talking about the skin area or the medical device that's going to be going and cutting the skin? So context is, what do we mean by this word? What do we mean by this phrase? So what do we mean by adding context to textual data? It means that you understand your business. And once again, it has different meanings in different areas, because your business is different than the business right next to you. And the desires and needs of the other part of your business means different things for different contexts, matter the documents that we're trying to analyze. So we need, first, it could mean extracting key elements and phrases for categorization. And categorization is going to be different for different needs. So the first thing, we're to apply context, we must first pull out the words that mean something to us. So we have to organize our documents first. We have to then organize our documents format them into text. But when we have that text, we must put it into buckets of, these are for your area and these are for my area. So we're going to extract the key elements out of those textual documents. And then we're going to aggregate the terms into layered categories. Because when I talk about, if I talk about my finger, well, I'm talking about a part of the body, but I'm talking about part of the hand. I'm also talking about part of the arm which is part of the body. It's a layered category. And I want to know where in this particular layer we are. But what part of the finger? Am I talking about the blood that's going through the finger? Am I talking about the skin on the finger? Am I talking about the bones inside of the finger? Am I talking about the nervous system within the finger? So different things are going to be different to different medical professionals. But we need to be able to aggregate the terms into layered categories. Consider this very similar to data governance within a data warehouse. We've all dealt with data governance. And what we need to do is have subject matter experts that are going to define which terms mean something to me and which categories do they fall into. So I must have people from business, subject matter experts, work with us to make this happen. Then we have to understand what dimensions you want for analysis. What are classifications that are important? Because I could say finger, I could say digit. There's a lot of different ways of talking about the finger. I'm going to use different terms in different situations. And as we move from one dialect to another within the same language, much less across languages, we need to be able to aggregate different terms into a single classification so that we are all talking about the same thing. We're just talking about it a different way. It can be very highly political between your different departments. No, it means this. No, it means this. It's a part of my neck. It's part of my reproductive system. That's fine. It's nice. It can be both because it is both. It's trust within a friendship, within a computer world, within a financial world. Yes, it is. But I need to make sure I know what dimensions we're talking about for that analysis. So there's highly political things whenever you deal with data governance. But the key here, it is controlled by business. It cannot be controlled by IT or data analysts. It needs to be controlled by business. It is like data governance. If it's owned by IT, it's useless. So what is the process that we're going to do to add subject matter, context to our textual data? Well, it really matters what analytics you want to perform on your text. What are you trying to do? So no matter what, well, you probably have to do some type of data conversion. All of those formatters, once we have the documents in different areas, we're going to use these formatters to bring them all down to a common textual format. But if all of the data that you need is already in that format, then maybe you don't need data conversion. That's fine. You may need data redaction. We talked about that. We have to remove some of the data, cross out some names so that to protect the innocent. Also for legal ramifications, especially when you're dealing with medical records or insurance records or, well, personnel records, we may need some redaction. Remember, we're not looking at the individual. We're looking at the aggregate. The key with textual data is to switch your view from the individual to the aggregate. No matter what, you're going to have to do some data extraction. We are going to have to set up the context that we want to extract and pull that data out of the text that you have. So we need to identify important phrases, important areas that are important for your context, for your needs, for your analysis. At Forest Rim, we call this a nexus. It is the joining of the phrases and words along with the categorizations, the layers of categories that you're looking to use. You're going to then run it through an engine to pair the nexus with the text to do the extraction and put your data into a structured format. The key here is that the nexus, the contextualization, the layered categorization, and the engine work together. The engine extracts the data from the text that is important to you. It's no different than trying to extract those perfect tones from the flute section so that I could hear that melody, while at the same time the French horns are bringing back a harmony. That's what we're trying to do. That engine is what makes these things work, paired with the nexus. That's the context. That's the difficult part. Once you do the extraction, you can do data transformation. And we can classify the match nexus phrases with their classifications. So this also is a time within that engine to add metadata. We can add to each of these terms, we can add dates, we can add sentiment, we can add sentence information or byte location. Where was this term in the document? Where was this term in the sentence, in the paragraph? Was it towards the beginning? Do we always find these at the end of the document? Is this something that we found our people like to talk about early, middle, late? Because that gives us an idea of how we have to interview our people or make sure that they understand it a little bit better. So that's byte locate. It's very important. I can get batch numbers or business that this deals with. What nexus did I apply this to? Because applying this set of documents to this nexus, to the diabetes nexus, will have a very different outcome than when I apply the same set of documents to a nervous system nexus or a COVID nexus. And also, I'm going to add parts of the customer to this. So there's lots of other metadata that we can add to this. But once we extract and we transform, obviously we need to load. We're going to load that data into our data warehouse, into a data mart, into Parquet files, whether we're looking to do structured data analysis or AI and machine learning analysis. We need to do a textual extraction, transformation, and load. And this is done by using a nexus and an engine to make this pairing happen. And thus, you can now have your unstructured data, your textual data, in a format that you can use for structured data analysis. So, what can be done with this contextualized data? Well, we can do structured data analysis. What kind? We can do a document markup to visually identify parts of the document. We can do sentiment analysis, which gives us feelings, degrees of feelings, and how our customer thinks or how they like their opinions of different classifications based on parts of the document. We can do inline contextualization. Inline contextualization, the best way I can explain it, think of it as a reverse mail merge. You have a contract with all of the pieces inside of the contract, and they're standard pieces. And all we did was put names and dates and terms into different areas. How can we pull those back out? Because all I was given was an entire cabinet full of contracts to scan in. And I want to know how much money was in those contracts, how many people needed this particular piece of that contract, how many people, how many pieces of property, what was the average amount of worth of the property in different zip codes. Well, they're all in the contract. I want to reverse mail merge out of that contract and get my data set back because everything else is boilerplate. Inline contextualization is a reverse mail merge. And we can do document classification. We can give context to areas of the documents and then look at all of the documents so that we can get a correlation analysis, or we can do basket analysis. These are standard analytic tools that have been generated and cultivated over the last 40 years. Well, in the case of correlation analysis, the last 140 years, but that's okay. So let's go through each of these. What are you talking about? What is document markup? Well, it's a data visualization. It's color-coded. It draws the eyes. And I'll tell you what, NLP does a great job of this. It really does. It does a nice job of letting you know subjects and verbs, and I can color-code them and say, here are some nouns, and here are some verbs, and this was a sentence, and these don't agree, and I'm going to put red underlines underneath them so that you can change the email while you're writing it, so that you can grammarly up your entire document so that what you send is proper. What you send has tact to it. But this is document markup. It's what we do with HTML. It's what we do in a lot of different areas, and it marks up your document. You can see where things are loved and where things are disappointed and where things are good or bad. It draws the eye to these areas. It is wonderfully used by document. It's used document by document. I need to look at this document, mark it up, look at it, and say, yes, I see these, and here are the highlighted points, just like you did in freshman English. You highlight with different highlighters so that you can remember different parts of the book. It's great for spot review. This is wonderful for spot review. But we're not looking at spot review. I have 10,000 Yelp reviews that came in this week. I'm not doing spot reviews. This really is irrelevant and impractical for analyzing big data. It's the cherry on the banana split. But the cherry is just the extra piece on top. And yes, it's nice, but it's a single bite. And many people toss it off. It's not necessarily something that is hugely needed, but it is really, really cool. And for spot review, and when we want to go in and really look at these documents, it is a necessary tool and an excellent tool. So it is something that you need to be able to do. Well, what is sentiment analysis? We talked about it, but we're going to use a similar document, actually the same document. This assigns feelings to words. It's color-coded. It does draw the eyes just like a document markup, but it's another step on top of that. Because in this case, the color coding means something. Because my husband is just my husband. It's a bland word. It's just my husband. We come here because I love clam chowder. I see a green that is wonderful and bolded and strong. I have a love of clam chowder. Today, we're very disappointed in the clam chowder. So I both love and hate this. In the same, just sentence by sentence, it is love and hate of the exact same thing. But when you look at this, when you're doing sentiment analysis and when you're doing contextualization of this, clam chowder is a meal. It is a menu item. It is something about Red Lobster. Yes, I did pull this from a Yelp review of Red Lobster in 2017 in Miami. But this is clam chowder. It was bad. The cup was bad. It was too expensive. But my waiter was there. My broccoli was there. I didn't know anything about them, but my salmon was small. It was small. My mashed potatoes were expensive. It was only a scoop of mashed potato. But right after that, my waiter gave us good service. So I am happy about a menu item, mad about a menu item, terribly mad about a menu item, but happy about my waiter. And I'm happy about my service. I have classifications within this document that I can pull out. I don't need all of the text. I need to know how people felt about the different areas of my business. So we try to identify and categorize opinions stated in the text. So when I just don't look at the one, but I look at hundreds of these. We look at hundreds of these different types of opinions. We can categorize them so that we understand people liked our beverages a lot, but they also didn't like our beverages. They had some against, some above. We were wondering, one of the questions was what data modeling approach would be used to consider the structure that was originally in the textual format. The textual format just needs to come into a common format so that we can extract it. So the original format of the document doesn't matter because we're looking for the terms and the feeling and the areas that are important to us in those documents. It's not necessarily the format of the text. It's how we pull from that text. It's adding the context to certain terms, the clam chowder terms, so that we can say it was good or it was bad, that my table settings were atrocious and okay, that my meals were bad, but man, we go to Red Lobster because I love the Red Lobster, but at the same time, I had some bad meals. And when we add additional metadata to this, we can find out location by location where we are doing well, where we're doing poorly, and then we can go in as an undercover boss and find out why is this location loved when it comes to the dining area and hated when it comes to the meals. So we're trying to identify and categorize these opinions. And when we do this, this can give you a better understanding of where you need to focus as a company for your customer interaction. It's also great for comments. If I have 10,000 Yelp reviews, I want to know, in this case, the new Samsung watch. 50 different times, people praised its design. They loved its features. They said how easy it was to use. However, they didn't love the battery. They thought it was too bulky, and they did not like how it worked with apps. But this gives us an idea of where these are and allows customers to then go directly to those files, to those reviews inside of your company. And then that's where the document markup, because then it's document by document. It's very useful. You can, one of the points that was put out there, and I'll go back real quick, so you're right. With the Red Lobster, I have a date. It's not just a location, but a date. I can see how we can track the sentiment over time. Oh, it's not just now, but now we're truly doing data warehouse data where I can see sentiment over time. But we use these for comments. And the fact is, this sentiment analysis is a basic requirement for voice of the customer analytics. If you want to know how your customers feel about your initiatives, about your products, about different areas, you need to be able to do sentiment analysis. It is key. And sentiment has many ranges of sentiment. The problem is up till now, people have just considered, I like it, I don't like it. There's a whole lot more to sentiment than it's good, it's bad. The fact that it exists is part of sentiment. If I go to a hotel, I didn't say whether or not the breakfast was good or not. I want to know, is there a breakfast? Because the good may just be the fact that there is, especially in today's world. What about this next? What about inline contextualization? So I called it a reverse mail merge. But what we're trying to do here is to pull out terms that have value. So we'll go back to our Red Lobster area. I want specific values that matter. I want to know the date so that I can do historical analysis and time review. I want to know the location so I can do location by location analysis. I want to know the ratings that happened here. So what things happen with different ratings? What's interesting is that the more that we do sentiment analysis, we can actually back up the star ratings. The 2-star had, and this, if you're looking at this, you can see a lot more red than you see green, and a lot more dark red than you see dark green. It makes sense. It's a 2-star rating, and it's 2-star backed up with the sentiment analysis. So this is inline contextualization. Now you can say, well, it's easy. The date's right there. I can read it. Tell a computer that. This is not the easiest thing in the world, but it can be done. It is being done. We're doing it. It's right here. I see the date, and it's right after the date is the date of this particular rating. Right after the location is the location of this rating. It was a drop-down list, but this is how the data was dumped upon us in a blob of text. Let's take this another step further. It's very useful for contracts because generally in contracts, it is the party of the first named here and the party of the second named here. I can usually get this information out. Kind of tricky, but it can be done. This type of reverse mail merge on a standard boilerplate contract can be very useful to get your data back to where you need it. It is definitely needed for redaction. If I need to remove names, patient names, customer names, so that we can protect the innocent, you have to be able to do inline contextualization. And yes, it's easier said than done, but it's possible. Is it? I want to put it out there very clearly. None of this is an exact science. But if we've learned anything, exact sciences aren't exact sciences. There's got to be play on both sides, but for every time that I'm wrong about a word, you're right about a word multiple times. So this is not perfect, but in the aggregate, it's really, really darn good. That's why you need the spot checking. That's why you need the document markups. But let's take this. It's needed for medical separation, for document separation, for medical visits. Because when I'm getting the history of the document, of the patient, I have today's interaction with the doctor, and it's on a very nice format. But when I'm looking at the medical history, it may have been imported from another company. It may have been imported from another medical center. It may have been imported from another language. But usually it'll be visit with a visit and a visit and a visit. And I need to break these visits up so I know which things happened on which dates. So you need inline contextualization to break up massive documents into their relative documents, but I can still associate it with the characteristics of the patient. So let's look at this. I may want to retrieve group data from blocks of text. This is a medical, it's redacted, medical record. The patient has a history of COVID. I can see that they have acute bronchitis. They have a fever, fatigue, cough, diarrhea symptoms, and allergies. That's great. I'm able to pull that data out, and these are all positives. Not that these are positive things to have, but the fact that they exist. Whereas if they said no findings of COVID-19 or fatigue was negative, I need to be able to break those down as not existing, which is, it's a different term of sentiment. But I want to know all the people who had COVID versus not had COVID, that they were not showing. So that is some sentiment, but it's only, it's binary sentiment. It's Boolean sentiment. You had it or you don't. But more than anything, I need to know what drugs these people are taking. And all you're given is a blob of text. I know that I see that they have aspirin down here under medications, but I don't know how much aspirin they were given. But I did see that they were given, I'm sure that I'm going to destroy this, but dextromethorphan hydrobromide. How much? 1 milligram. I need to know how much of each drug this particular patient has, because I'm looking at all of the patients who are in this age who have COVID-19, who survived longer than 2 weeks, who have this type of allergy and took this drug and this drug. Now we can do some microsegmentation. Now we might be able to, from a massive amount of tens of thousands or millions of medical records, be able to start seeing those that text mining, that data mining that we can pull back out. But it's inline contextualization is more than just finding a date. It's being able to find contextualized data, not just the drug, but how much of the drug was given. And was it given just by a milligram or an oral tablet or an injection? That's inline contextualization. And that has worth because now this is put into a database that we can search. And we can apply it to COVID patients. We can apply it to diabetics. We can apply it to people suffering from diarrheal symptoms. And what is document classification? Well, document classification gives context to the areas of a document. It is very similar to what we've done in the past, but it says, I want to know what areas we've dealt with before. I want to know that we've dealt with menu items, and I don't care that it's clam chowder or salmon. I want to know that we've dealt with menu items in this area at this time. I want to know about ambiance. I want to know about meals. This is the data governance part, the layers of contextualization that need subject matter experts, because they know what the KPIs, the key performance indicators in my business are that allow me to compete. I better have good ambiance. That's who we are. I better have a good meal. That's who we are. But we understand I'm not worried about some of the other pieces because that's not what we're looking for. So we're trying to give context to different areas of the document. Take it out of the phrases. I'm not worried about the specifics. I want to know a step above the specifics and aggregate those together. We can then do correlation analysis. Who had parts of the body that was problematic? I want to know who had cardiovascular issues with diabetes. Well, there were 5 people, but there's a positive correlation. Green means positive. Red means negative. I'm sorry, these are generally bad uses of color. We've learned this in data visualization. You don't use green and red because of colorblind. You use blue and orange. But in this case, if you are colorblind, I'm sorry, then it is what it is. But here I can find out how many people had diabetes with cardiovascular issues. I can find out how many people had, how many documents in here had issues with their gastro areas and cardiovascular areas. And we can find out, are these positively or negatively correlated? This allows us to do a Pearson correlation analysis based on categorical data instead of specific word data, because our subject matter experts said that anytime that I'm dealing with this, it's in this area. I can do basket analysis. This is a beautiful type of analysis because now we can take the words and phrases that we had, classify them, and find out when someone talked about this, they also talked about this. When someone purchased diapers at a Quickie Mart, they also purchased beer. It allows me to know what's in the basket. And this can be used in so many areas. It could be used for Red Lobster, and they talk about the meal and the service together. And do they talk about it? How do they talk about it together? They can talk about COVID and diabetes, or this drug and this area with this specification. Basket analysis allows you to really evaluate in a quick picture how different areas work together to see that nugget of information that allows you to advance on your research and make better business decisions. You can do mind maps, because now I have an idea of what things happen the most, and within these, what did they connect to, and what from those, what did they connect to, and how big of an area are these, and how difficult or how often are they connected. We can also do knowledge graphs. We can do a tiger graph. We can do any type of mind graph or knowledge graph here. This particular one's about Harry Potter. So I want to know all the different characters in Harry Potter and how they interact with each other. So this allows you to create nodes and vertices and see what the strength is between different nodes or different areas, so that you can see a cause and effect, or at least a correlation on a larger scale. These can get large and confusing, but at the same time, when you look at them from a smaller area, from a node to node, you can get a jump to jump on what's happening. This is what happens when you do document classification, and this can be done if you can contextualize your data, if you can add the nexus, the contextualization, the data governance with the engine, and allow the engine to extract that data so that you can come up with a strong knowledge graph. So let's review. There are many types of data in our data lakehouse. The key is it's curated. It's data that we have metadata about. We have other things that we can talk about and use. There's a little bit of structured data. There's a lot of textual data. There's a massive amount of machine-generated data. We are going to use the structured data in a data warehouse. In that area, we already know that this has been a conductor in the entire percussion section of our orchestra. We know that the analog has an IoT data comes in Parquet files because they're binary files or columnar data, and machines can work through these tremendously fast. They have great capabilities to do AI and machine learning. But that is your brass section. And now with the textual data, you have the flutes, and maybe you have not the violins because we've already dealt with those, but maybe you have part of the brass section inside the textual data, because some of the parquets could be textual. And now with using the extraction, transformation, and loading, the textual ETL, we can turn our textual data into stuff that machines and AI can use and data warehouses can use for business decisions. What's the process? Well, first we have to sort our textual data documents by types so that we have an understanding. And this is multiple types, because there's the type of document being what context are these documents in, and what are these documents themselves. Then we need to convert our textual data into a common format. We may need to de-identify data if you're going to store it, just for legal reasons and for protection reasons. And then the key is you're going to apply the context to your textual data. When you apply the context, you can convert your unstructured data into structured data. Once you have converted it into structured data, you can now do structured data analysis. You can do document markups, which have their place, they have their use, and they're really a nice tool, especially a proof of concept, a spot checking, and customer by customer, you can use them. You can do sentiment analysis so that you can understand the feelings, the opinions of your customers. You can do inline contextualization to pull out key factors, key specific points from your data, so that you can do that reverse mail merge and store that into a format that you can use in a structured area. And you can do document classification. This allows you to do so many other things. And there's lots of other pieces once you have structured data. These are just ideas of what you can do with your text. The key is you're storing text. You're storing a lot of text, but you're not using it. You may say, we're reviewing all of these medical records to find out why something is happening. Yeah, you're not. You are using my voice of the customer that we just paid so much money for this survey company to give us, but all you're getting out of is a star. Why not get so much more out of it? Why not use that document, add context that your business decision makers, that your business professionals understand, and using dimensions that they need, and pull that data out. What kind of questions? We have a little bit of time for some questions. So is there, so one of the questions, there's a possibility for the source data to provide semi-structured data using an API. Can you use the source data? Absolutely. So when you're dealing in Parquet files or in CSVs, if you're dealing in a tabular data file, a lot of times the data has key fields that you can pull out right off the bat. So you could use an API to pull those out and marry those to the text, but then you still need to add context to the text so that you have more fields that you're looking for. Can you do this? Yeah, you can. So how do we break the different cycles of interpretation in text? One thing that you're doing with text is you cannot, no different than when you're doing a text or you're doing an email. A computer can't pull out sarcasm. Most humans can't pull out sarcasm. So when things are going through, you have a problem there. But one piece that I would say is when you're dealing with the data governance, possibly be more liberal than conservative when you're saying, this is what this word means. If you only allow one meaning of a word, you're restricting yourself. What's nice with a good nexus, with a good layering, if the word means two different things and should be allowed in multiple areas, even within the same area, then it needs to be there twice. And you say, well, that breaks primary keys. People, we're not dealing with primary keys here. We're dealing with aggregated data. So I don't know. I can't interpret exactly what you meant by dermatome in this particular area. So I need to make sure that it could have meant a part of the skin, part of that organ, or part of a medical condition or a medical instrument. How do you account for spelling areas? Account for incorrect sentence construction? This is a great question. The first thing is, if you're doing it through a proper engine, we're not doing NLP. NLP needs that sentence construction. It needs verb-noun relationships, or at least it will let you know if they're not there. That Red Lobster, my gosh, the person obviously didn't know how to use the shift key except for using the dollar sign. Everything was small. Okay, and the ampersand. But everything else was small. The nice thing is, I'm not worried about sentence structure. I'm worried about parts of the sentence. So we can do that. Now, the other piece, a great piece, how do you worry about spelling errors? Any type of engine and nexus needs to be able to handle acronyms. It needs to be able to handle, so when I say EKG, I actually mean an electrocardiogram, which is funny because that should be an ECG, but lock and load. It's not always in the right order. But one doctor is, well, I'm going to go down to the medical line. If you had chest pains in the current version called an ICD-9, which was how we dictated chest pain, you put down as a chest pain. But in ICD-10, that became a pain in the central trunk. Well, that doesn't make a lot of sense. But if I can pull out pain in the central trunk and chest pain and make them in the same classification, I don't care how you said it. I care that you said it. Because either way, I'm going to classify both these into this area, and then in this area, and in this area. I need to have that information, but it's not how you said it. You may use, one doctor will use a term or a set of terms to mean the exact same thing another doctor will use. There's very little, for all the standardization that a EMR was supposed to bring us and all the love that an EMR was supposed to bring us, really what it did was bring us a lot of text in completely different ways. Let's bring it back together. Great question. Would I have to implement multiple language to implement a single contextual language? Possibly. It's a fabulous question. We may have to look at, if you're looking to bring everything back to English, then I need to have all of the words and the phrases in different languages brought back to the English contextualization. The answer is yes. If you're looking to just do it in each language, you have to have a different nexus for each language. And even within that, you look at American English versus British English. We mean something completely different than a tube. When we say tube, a tube would be a place, or would be a tube of toothpaste in the United States, but it means it's in the underground inside of when you're in London. I'm going to go into the tube. So it means different things in different places. And so we have to be able to make sure the context and where we're getting those documents fits the people that we're getting the documents from. So my suggestion would be, if you do need to break down your documents so that you're applying the correct nexus to it, but you may need to have a separate nexus by language if you're bringing them all back to the same central language. So the answer is yes. This is one of the statements, especially people who've done sentiment analysis. And I found this to be true, that sentiments are, when you're looking at sentimental languages, 3/4 of the words that and phrases that deal with sentiments are negative. How can you balance that? How can you say, well, what's interesting is there's lots of ways to say something's bad, but there's not as many ways of saying something that's good. But people will still give about as many good or bad based on the situation. So even though there's a lot more sentimental negatives, that just is. It doesn't necessarily come out that way in analysis. It comes out pretty true to form in the analysis itself. But that's a good point. Let's see. I'm not sure if I missed any others. I've really enjoyed being here with you, and I hope this has been useful. I keep on learning every time that I talk about this, so I'm hoping it's useful for you as well. I would like to say thanks, because as Adam put, how do we say this in all the different languages? Well, we have to be able to. But I'd also like to thank a lot of people that I use for resources here. So I do appreciate everything that you've done there. But otherwise, if you have any other questions, I'm happy to talk to you. How would a business contextualize contract document to analyze the data for business purposes? Well, you have to look at the context of the documents, and the inline contextualization would be set up by contract. So it does take setup time. As Abraham Lincoln said, if you're going to give me 6 hours to cut down a tree, I'm going to spend the first 4 hours sharpening the knife. In order to do this, who would do this? You would need to have someone understand the general areas of the document and understand where I'm going to be pulling data from. And so that would be the contract expert, and you would do a set of documents at a time. So that would be that would just generally be the contract expert would say to the person handling the engine, this is where things are. Can you pull these out for me? Primary tools for inline contextualization. it requires the ability to do contextualization to begin with. So we have to be able to do you need that nexus. You have to understand terms that we're looking for as well as phrases that we're looking for. And then adding context to those definitely helps. Turning those into a different set of nexuses so that you can group them together, allow you to understand different parts of the document and where they're coming from and how you're pulling those out. But then we also have to have rules, lots of rules that allow us to do different things. So that would be the tools. We've been able to, at Forestrom, we've been able to create our own tools for this, but I haven't seen many others. So I don't have a good answer for you outside of ours, but that's not the purpose of this speech, this talk. It's not to say, hey, we've got the answer. It's to say that the answer is out there and we'd love to help you make that answer, be able to use that answer, but it is a lot of sharpening of the blade. Other questions? So I know we have Valerie. Oh, yes. They are not managed. So a nexus is not managed as custom code. A nexus is managed as a grouping of terms. A nexus is based on an oncology or a taxonomy, but that's not what it is. It's a lot more than that because those can go far too deep. They can go and not have a lot of context come out of it. But it is managed as a set of rules that then can be added to, removed, or modified. And when you have a base set of rules, you have a starting place, but it's going to be different customer by customer and issue by issue. So it's not necessarily managed as custom code, but rather managed as a grouping of context that you need to use. So Dr. Valerie will be up next. She's going to be working with you, and I'd like to say thank you very much for spending this time with me. I'm hoping that we can do this again in the very soon future, and I hope that this was useful for you to see how you can use your text and that it can be used in your structured world. And hopefully, the flute section, and the French horn section sounds a little bit better to your ear than it did before this presentation. Thank you so much for your time. And at 1:30, we look to seeing you back again as part of the symposium.
Thank you, Dave. Dave, I would like to amplify one of the answers that you gave, and I want to tell you, everybody, a little story. A while back, we were dealing with a restaurant, and we looked at the comments coming back to the restaurant chain, and far and away, they were negative. And we were working also with a consultant who is and I didn't even know they had such things, who's a restaurant consultant. And we were showing him the results, and it was kind of interesting. He said, Bill, he says, when you are dealing with analysis of sentiment from a restaurant, you expect to find negative comments. And I said, well, why is that? And he says, when people walk into a restaurant, they have the expectation that they're going to have a good time. The food's going to be good. The service is going to be good. That's what their expectation is. And as long as the expectation is met, you never hear anything from them. He says, however, if the expectation isn't met, if the food isn't good, if the service is bad, if the table is dirty, if the restroom is dirty or something like that, that's when you hear negative things. So our consultant, who, by the way, is a really, really smart guy, our consultant said the normal expectation, because of the beginning expectations, the normal expectation for a analysis of sentiment for a restaurant, a normal restaurant will get 85% negative comments and 15% positive. He said, if your percentages are different from that, then something else is going on. But because people don't make comments because of positive meeting the expectation, but only make comments because of negative. That's one of the reasons why you get a lot of this negativity. Anyway, I want to just amplify your answer for that. I now want to introduce to you Dr. Valerie Bartel. Dr. Bartel is a professor at Denver University, and she's going to continue our discussion from an analogical standpoint. We've heard the violins play, we've heard the flutes play. Now we're going to hear the French horn play. So with that, I'd like to turn it over to Valerie.
Thank you, Bill. All right, so yes, this is part of the French horn that's coming together to compose the whole picture of this textual analytics. Mine is looking at structured data as well as some unstructured data, because when you're doing analytics, even if you start in an unstructured format, when you come together to do analytics, usually, and like what Dave mentioned as well, you're going to have some sort of structure that the textual analytics will go into before you actually then do your visualizations. So I will be discussing the big data lakehouse, ethical issues, best practices for the visualizations, some examples, and then hopefully we'll get to a visualization demo as well. So with big data, some questions that you might want to be thinking about as we go through this presentation. You know, why do we care? Why is this important? Especially, does every company need this big data? And then what are some of the downsides of big data? So it's not all bright and rosy. And so something just to be aware of making sure your business is focused as far as what it needs on what is important to them. So just some realistic issues and some challenges with the data would be that volume. There's so much data out there, where to start. That's a big issue. Velocity, which would be the amount of time that can take to analyze the data, especially based on what your focus is on the analytics process. And then the variety, which would be having enough data to be able to answer those business questions that you want to figure out. And then also the cleanliness of the data is just making sure that everything is ready to be analyzed. This can take a lot of time, a lot more time than people realize. So if you're and have been doing big data, this is probably something you're very familiar with. But just to get that out of the way at the beginning, I wanted to go through that. So lots of voices from the industry indicating the power of the big data. For instance, the senior advisor to the CEO of Microsoft is saying data is becoming the new raw material. It's offering information into insight. The world is one big data problem. So data is just starting to be in charge of everything that we do. And what my students enjoy is the quote, I keep saying that the sexy job in the next 10 years will be statisticians, and I'm not kidding, the chief economist of Google. So just lots of data. That's the power of the future, and something to really get a grasp on as far as, you know, what you need as your company to go through and be successful in the analytics process. So what we're really interested here is this sort of data mining, which would be looking at patterns, maybe for targeting promotions, for mixing and co-location of items in stores. also for finding hidden patterns. So this could be something, and building off what Dave had mentioned with the diapers and beer on Thursdays in stores that people sell together. Also, Walmart found that during hurricane season, not only do batteries sell and things of that sort, but before a hurricane, strawberry Pop-Tarts are very popular. So who would have known that unless there was some patterns that was discovered behind the scenes when looking at the data. So basically, being able to distinguish these patterns, the same issue goes back to text as well. So if we're talking medical records, you know, what would be some patterns or correlations that could relate between and among different items and context within the medical record realm. So for instance, here we have in medical records, of course, medication is very large. And in this simulation medical records, we also have oral over here and tablet. So these are some issues that are connected. And if you see this zooms in on oral, and it's got some correlation to throat, among other things. So this is the power of doing the analytics, is really going behind the scenes and determining how things fit together in some logical, or maybe not logical pattern, but some things that are new insights. So now we're looking at finding the value within and outside that conventional data sources. So for data lakes, this is where you have lots of data formats coming together, images, text, audio, etc., and how value is going to come from all of these different angles. So ultimately, business intelligence is what everyone's aiming for at the end of the day. That's usually involves often intuitive situations, questions that you want to answer. It's contextual, so usually based on a company's interests. Actionable, so something that a business can follow through with at the end of the day when they find out specific patterns and insights. And so therefore very strategic for the business. And along that line, when we're talking about other specific areas like customer data, so that is very helpful also in making strategic data. There's lots of areas like e-commerce that's budding field right now, where lots of information can be found. As Dave mentioned, the customer reviews are very important. Call center data could be helpful as well in finding out trends and analyzing and figuring out what the customer wants. Also, we have this social media explosion today. So they call it sometimes the share, like, buy generation, where people are determining what they like and they're sharing it among others and friends. So this is where textual analysis could come into play, and just finding the different patterns and what is being touted as something very interesting and something maybe not as much. So something to think about would be the business intelligence development lifecycle. There's a few stages in that, defining those key performance indicators, those metrics and concerns that are important to the business. That's very, very important to determine upfront. And then determine the goals and the project statements that you'd like to solve. Identifying the data sources to help solve the problem. So this is going to go back to whether you have the data and what you need to get the data, and also assessing the data ecosystem, which would be what you need to compute with and store the big data, and the potential of the analytics as a result of that. Also, is the data that you need available, or is it something you need to collect? Because it's not worth collecting if it's already out there and publicly available. And then how are you going to access that data? Where are you going to put it? If you have lots of data, that's where the data lakehouse comes into play. And then actually going out and collecting the data. And finally, to make the data valuable would be to develop reports and dashboards so that it really will get down to answering those business questions and the project goals that you may have in your company. And then going back with quality assurance, testing with the business stakeholders. So making sure that expectations are clear, the methods are evaluated, and guidance is involved with the process. So stakeholders are very important to involve, and usually even towards the beginning stages as well. And then you can, once approved, start the whole process that you've laid out. So it's very important to have a certain mindset and a goal for where you're aiming to end up before you start doing anything. And that's what I recommend for throughout when you're doing the analytics and the dashboard as well, to always have a plan. You want data to be an asset on the balance sheet. So be careful, there's a cost to producing the data. There's also a cost to replacing the data. So at the end of the day, though, you want revenue or profit opportunities. And be careful, the revenue could be lost if the data falls into the wrong hands. So legal exposure is a danger from lots of data, historical data, consumer behavior, especially when Dave was mentioning de-identifying the data, especially in medical records. That's very important to have a good handle on, like we are doing here at Forest Rim. And then some use cases, that's something to maybe have a focus for your ultimate goal of the revenue and profit opportunities. So looking at the data's asset, looking at it in that angle. So lots of different areas you could focus on. It could be something like financial fraud detection and intervention, doing different loan risk analysis and insurance policy underwriting. I know there's a company in Arizona that is able to determine based on text whether the person is going to default on the loan, which is very important to know. Customer churn analysis is something that would be another important thing for a business to consider and look at. And then also when we're focused here at Forest Rim a little bit more on the medical aspect. So medical record analysis, lots of rich tests available that you could then put into some sort of context. So when we're looking at keys to success in analytics, and this would be leading to business intelligence again, teamwork is very helpful. So being able to brainstorm with each other, to learn together, to ask questions of your stakeholders as well. Many iterations, things might not, of course, be perfect the first time around. So with that being the case, don't be afraid to alter from what you first started from, because there's never one right answer, and often the best practices could be guidelines. They're not exactly always precise that need to be followed. So something to take into consideration. When we're talking about reusable analytics, that's very, very important when you're working with needing a lot of analytics done. If everything is custom coded, then there's going to be lots of issues for not being able to really prosper in what you're doing time-wise. So that's why it's good if you're interested in doing textual analytics or something of that sort to partner with a company who's doing it really well, so that you don't have to reinvent the wheel, and then that company is doing things very consistent. And then something to take note of is the complex event processing. So that is going to be when you're processing events, both inside and outside of the organization, but you're doing action in real time. So this could be something that your company might be interested in, as far as text messages, social orders, customer service calls, anything that might need that real-time analysis. So social media posts would be something else. And this is a table that I find pretty helpful if you want to go back to and kind of determine, you have a lot of areas that you want to do and to prioritize what you need to get done and what would give you the biggest bang for the buck. So if you're looking and you see the start area, that top right quadrant of the high business value with the low level effort, that's often something that you can strive for first. So, you know, it's good to put everything you need in all of these quadrants and see how they fit. And then maybe that could be some guidelines and some sort of rationale for tackling the first thing that you want to look at and analyze. So time series data, this is very important. It's important both for structured and unstructured data. But for forecasting, for instance, if you're going to determine, like you have medical records for COVID patient interactions. So today it's a certain amount. Is it going to be the same in a couple of years? So that sort of mindset and trying to get a statistical package that could then help with this forecasting using time series data. Also, as we're going to talk about as well, it's good to look prior as well. How was it last year? Maybe use that and this year as determining factors for what's going to help in the future. So just another angle to look at things. And then we have the operators of drilling down and rolling up. So this is something to consider, especially for business intelligence. So if you're interested in looking specifically at the daily text feedback that a company is receiving, then you're going into more the drilling down component versus rolling up, which would be looking more quarterly, annually, even seasonally at different trends from feedback that your company is receiving or any other area. So this is an example from a simulated medical record of drilling down and rolling up possibilities. So we have here all of the immunization in the medical records that has been discussed. and you can break it down then based on the different components of what was being discussed with immunization, such as influenza and these different vaccines. And you can drill down even further to the others area where that 1.7% will become available, and you can see what's in that area. And you can drill up back again to where this is. It's very helpful as well, because if you're working with medical records, you can quickly sort to find different context you're interested in, and then you could even identify the medical records here associated with that context. So that's going to save you lots of time. Automatically, we're going down to, say, 500 records that's discussing certain topics versus having 500,000 records that you need to sort through. So I think, you know, logically having 500 is always better at the end of the day, or less. So some practical things that could be done with the data analysis. So just for compelling issues for visualizations, and I'm sure that most of you are sold on visualizations anyway, but questions I often ask is what makes more sense? We have here this table with lots of data. You know, quickly trying to eyeball certain trends, it's kind of challenging over time and things of that sort. So versus if we look at a chart, so this is going to quickly, in one blink of an eye, be able to determine how trends are going, and then you can start making decisions as far as what to do as a result. And then, of course, there's also ethical issues when you're going about making charts and graphs. This here looks good at a glance, because in 2005, when Florida enacted the Stand Your Ground law, it looks as if firearms decreased the number of murders committed using firearms. However, if you look a little more closely, this graph is flipped. So in the United States, we usually have the zero axis. Oh, sorry, it went away. The zero axis at the bottom, the X and Y axis versus the top left. So doing things in a way that your people are anticipating is something that is being a lot more ethical, and people can glance and then understand versus try to really thoughtfully figure out if it's being done in an ethical manner. And then here, a lot of marketing will do this as far as truncating the bar graph. So here we have the bar graph starting at 9100. It looks like there's a big difference among these groups. However, if you have the bar graph starting where it should start at the 0 and 0 XY axis, the change is really minimal. So trying to be ethical in how you represent your data is going to give you the best idea of the direction to go and how to make decisions. And so making sure that you're aware of how certain things could be misconstrued is going to be very helpful in case some people are not as ethical in the market. And then just a couple of things. There's some important areas for rationale for choosing certain different graphs. So just looking at comparing the line graph and the bar graph, for instance. So this is looking at smaller changes, and usually the line graph is looking at it over time, and usually comparing groups. This is just one line, but if you see this is over time, and it's small changes that you can kind of see based on it being in a line, versus the bar graph, where you can tell more quickly the larger changes and you're comparing groups. So when you go back doing the analysis, make sure you're thoughtful in how you represent the data for the best that it could possibly be for telling a story. And then on the flip side, we have the bar graph, and there's also a horizontal bar graph. And this is helpful if you have lots of words on the x-axis or horizontally that you need to read, because you're always trying to think of what is more convenient for the viewer of what you're doing. So that's just one example of a couple of graphs of why certain charts and graphs are chosen over others, in case you haven't thought about that. And then also being mindful of just the overall dashboard design. That's always very helpful. If you see, hopefully you'll agree with me that the top dashboard is a little more appealing than the bottom. And why is that? There's a lot of different reasons. For one, the top is in one dimension, where if you're looking at the bottom, there's multiple different dimensions being represented in the graph among all the different graphs, which makes your eyes kind of jump around versus stay stagnant in one place. Usually it's a good idea to stick with white, choose gray as the other color, be intentional for your colors. So maybe it has meaning for your business. As Dave mentioned, the red-green colors or anything that's not suitable for color blindness should be steered away from. And then, you know, add the colors if it tells a story. So less is more. And thinking about complementary colors and things of that sort, maybe just using 2 to 3 colors and the shades of those would, the different gradation would help to make your dashboard look a little more professional. As you see here, we have the dark blue and the light blue, different kinds of blues and greenish kind of popping up. So it's kind of sticking with similar colors throughout. And of course, the orange is kind of a complementary color to blue. So that's helping it kind of stick together as a whole. So when we go towards reporting the data best practices, Forbes says present to the right people at the right time and present it in a meaningful way for decision-making and performance purposes. So really try to be mindful of your audience and how you can come across the best way to present what you need to present. So that all comes with strategizing the tool you're going to use, the layout you're going to need, and the like. And when we are looking at reporting, it's actually an intersection of graphic design, user experience, and operations research. So all of these coming together to make an intelligent decision display so that at a glance of an eye, people can make important business decisions. So why is reporting important? Computer systems, they are good for what they can do. They're very powerful at the end of the day. But analytic systems, those are more tools for humans to be able to interpret in an intelligent way and to make sense of the data. So keep in mind, data is great. It's only a means to an end. So data itself is meaningless, and it needs context and analysis to have some sort of intelligence surrounding it. And, you know, keep in mind that in goal of business intelligence, it goes back to being very strategic and actionable in what you do. So there's lots of different types of tools available and features out there. Basically, you're going to probably want to choose something that best represents your data. So be mindful of that. And lots of tools are able to build graphical or tabular reports, which is helpful, or integrate the data sources. So bringing multiple data sources together. And then also have some sort of graphical design interface going on. If you have some sort of reporting tool that can be published, so it can be shared centrally, that could be very helpful. So these are just things to look for. Having accessibility for mobile and tablet support, and also considering the licensing fee, what your company is able to do in that area, and looking at support and user experience. Those are all things to consider. And as far as types of analysis, there's lots of programs out there. There's Excel, which is very good for people who have a low budget and are wanting a good visualization tool, but is already built into what they have in their Microsoft package. There's Tableau. There's Power BI. That's also a Microsoft product. ClickView, MicroStrategy, Yellowfin, SAP Business Objects. So lots of things out there you can choose from. And again, just being very conscious of what you need and how to decide what you need is going to be the best success for you. And I think we pretty much discussed the design principles prior. But for Forest Rim, currently we're using Power BI. There's other tools. We're not, we have used Tiger Graph as well. So we're not just anchored in one tool, but Power BI is pretty powerful. It has real-time charts and graphs. You can do trend analysis in it. You can connect to the external data. You can auto search data capabilities and find trends, like I mentioned, and it works with other Microsoft products, which is very helpful sometimes when you're working alongside of Excel and other projects that products that you want to interface together. And then it's also enterprise accessible, so you can add and remove users. It's cloud-based, so there's quick speeds along with that. And, it produces a pretty good quality dashboard for what is needed. So if we're looking at the overall dashboard, and in the United States, for people who read from left to right and from top to bottom, it's a good idea to start with the topmost graph or different analysis being the most important, or the overview of what you're looking at. So up here, this is an example of, this being the total overall tweets, retweets, things of that sort. So this is the overall picture of what they're doing the analysis for. And by the way, this is Power Pivot, so it looks pretty professional, even though it's just an add-on tool for Excel. And then here, and it's a free add-on, might I add, this is the more important overview of the visual. So we have tweets by day. And then we start looking at more specifics, like hashtags that are involved, the time of day, whether it's morning, afternoon, and what time during the morning and afternoon. So we're getting more specific and drilling down as we're going from top to bottom and left to right. And then usually on one side or the other, there's going to be slicers or different filters that in real time you can do the analysis different analysis and look at different trends in the data. So a real-time example here would be something like this, where you're looking at certain information. Here's back to immunizations. So we're looking at this based on different areas that might be relevant and important based on immunizations that are taking place. So how this is taking place based on gender, based on medical records being discussed in medical records. We have this based on marital status, smoking status, bronchitis. So we can drill down and be more specific with even, like looking at bronchitis or smoking or things of that sort. So these are, it's very powerful at the end of the day as far as, what you're looking at. You can take a look at, if you're only wanting to zero in on females, then you can drill down and this will tell you in real time how many females are married that are discussing influenza and pneumonia and things of that sort. And then another visual based on the same data is the discussion of the immunizations. This is just another look at it. So we have gender overall up here, and then it's broken down by age range. And then discussing based on each age range, what is being discussed. So if you're looking at the 50 and 59, then it's going to in real time tell you how many females and males during this, between this age range is being discussed with all these different immunizations. So hopefully people are discussing different things, 50 to 59-year-old range versus the 10 to 19-year-old range, where if you look, there's a little bit more tailored immunization-wise to what they would need during that age. So actually, I think that's about all I have. So we can open this for questions. So according to Gartner, this person says that by 2025, 70% of the organizations are going to shift their focus from big to small data. And then how is the Lakehouse, how can they support this market trend in cost-effective manner? So there is definitely a niche even today for smaller amount of data being used. It is it's pretty high up there still as far as the different money overall that these smaller analysis tools are able to do. So as far as the Lakehouse is concerned, I'm sure there's going to be still structure and support for that. There could still be lots of different areas and different data sources that is going to be represented. So it's important that the Lakehouse is available, but it's possible there could be more scaled down. It's possible that prices could raise if there's less people using less amount of data based on the market overall and how that's structured. That's an interesting, thoughtful question. And I'm not sure if I have the specific answer, but very, very something to think about. So thank you. Okay, so Power BI, they say it's limited to 1 gigabyte of data. So that is true. It's going to have issues with larger files. So that's something to be cognizant of. If you could somehow turn these larger video files and things into some sort of metadata that you could then analyze, that would be more specific and less volume, then possibly you could still use Power BI to get the job done, but that would be an additional step that you need to do.
Thank you, Valerie. That was a very good presentation. We appreciate it. This ends the second day of our symposium on the Data Lakehouse. Tomorrow, we're going to be hearing from one of the authors of the book on data warehousing, Ranjit Srivastava and Patty Haynes. And tomorrow we'll be talking about some different topics that we'll be talking about housekeeping and compliance and governance tomorrow. So we will see you tomorrow at 10 o'clock. And thank you for your presence today. We look forward to chatting again soon. Talk to you later. Bye.